Okay, we are on chapter 2, section 5. And in that chapter, we introduce properties of equality. And these are going to be very important to you as we move through our proofs. And they're all pretty logical. They're at the first group, the upper group. These are all algebraic properties we've used in solving algebra equations. So, and again, those will be applied to geometry situations. So in the first one, addition property, if you add the same number to each side, they remain equal. So if you take a look at this, we start off with if x equals 2. Then x plus 3 equals 5. Well, what did we do to the left side of the equation? We added 3. So we add 3 to the right side of the equation, and 2 plus 3 gets us 5. So again, by adding 3 to both sides, they remain equal. Subtraction property, same idea. If you subtract the same number on both sides, they stay equal. So if y equals 8, then y minus 7 equals 1. What changed on the left side? I subtracted 7. If I do the same to the right side, 8 take away 7 will leave us with 1. And again, we subtracted 7 on both sides. Multiplication property, same idea. If I multiply by the same number on both sides, the sides stay equal. If z equals 3, then 4z, we multiplied by 4, equals 12. And 4 times 3 would get us 12. Division property. If you divide both sides by the same number, the two sides stay equal. And that works as long as you don't divide by which number. In class, be sure to tell me which number you can't divide by. So if 6x equals 12, x will equal 2. Again, we divided by 6 on both sides to reach this new situation. Okay, the next three properties are properties of equality also. Substitution property says you can exchange part of an expression with an equivalent value. Notice here, if angle 1 is 3x plus 5 and I know x equals 4, then I can replace x with a 4 and find out that the measure of angle 1 must be 17, if I'm adding correctly. Reflexive property says any value is equal to itself. A must equal A, B equals B, C equals C. I like to think of that one as reflexive, even though it's not the same thing, like a reflection in a mirror. You see yourself across the way. Transitive property. If two values are equal to a third value, then they're equal to each other. If A equals B and B equals C, we can cut out the middleman and end up with A equals C. And doesn't that kind of look like the law of syllogism? I'd say it's probably its cousin, but transitive property you're going to use very often. Now, do be aware that transitive property can also look like substitution. And in fact, substitution always works. Substitution always works. Sometimes transitive property does not apply. Let me move my paper so you can see this. And that'll probably make more sense later as we move through our proofs, but for now, you just might want to take note of it, that substitution property always works, transitive property sometimes does not apply. And the last one, the symmetric property, that you can change the order of an equality. If you have A equals B, you can turn it around and say B equals A. I am not going to quiz you or test you on that, and that's why I put lines through the box. It's like, there it is, but we're not going to use it that much. I also wanted to bring up that these three properties, reflexive, transitive, and symmetric, are also properties of congruence, and that again is just something you need to know. It's not necessarily going to be a big deal breaker in the future. Okay, but do know that those three are also properties of congruence. And then at the bottom of the page we have distributive property, which you probably remember from algebra class, that if you have A times B plus C, you can distribute the A through the group and end up with A times B plus B times C. And the same can be said if you have subtraction, you can distribute again and end up with AB, take away AC. Okay, we're going to move on to page 2 and lots of examples. Okay, on page 2, we have some given statements, and then we have a conclusion that was reached. And what we're looking for is a reason, one of our algebraic properties, how did we get from the given to the next statement? So I like to ask myself, what happened? I will ask myself that. I'll ask myself, what changed? And those are good questions because hopefully you can suss out what the changes are. So we have 6x plus 5 equals 18, and then we end up with 6x equals 13. So what changed? Well, the 5 is no longer there. How would we have made that 5 go away? That's right, by subtraction. And if I subtract 5 on the left side of the equation, I need to subtract 5 on the right side of the equation. So that would be the subtraction property, abbreviated, of equality. Okay, take a look at the next one and take a second, look at it, ask yourself what changed, and see if you can come up with one of the matching reasons. Okay, so if we take a look, I asked myself, what happened? What changed? And so if I take a look at this, our conclusion sentence kind of looks like our original sentence. There's the minus angle R equal to 90, but what changed? Well, originally it had an angle Q in it, and now it has a 4 times the measure of angle R. We can see in the second statement, angle Q is equal to 4 times angle R, meaning any place I see an angle Q, I can replace it with a 4 measure of angle R, and that's what I did. And so what we've done there is I've replaced part of my equation, and that is substitution property at work. Did you get that one? We'll see. Okay, on the third one, take a look, decide what happened. Okay, so things are blurry while it focuses in again. If you take a look on number 4, or number 3, the answer was distributive property because all that changed was the 5 was distributed through the y minus x group, and we ended up with 5y minus 5x. And number 4, q minus x is equal to r, and then our conclusion. What do you think happened? Hopefully you got it. It's the multiplication property of equality. What changed was the original equation was multiplied by 4. Okay, and number 5. What happened? Did you get number 5? Division property of equality. And so you'll see that to get from the original statement to the conclusion, what changed? The 5 went away and it was being multiplied. How do you get rid of multiplication? You divide. And so 35 divided by 5 will get you 7. Okay, for number 6, angle A equals angle K. Angle K equals angle T. Conclusion, angle A must equal angle T. Okay, for this last one, Either answer is acceptable. Transitive property is acceptable because this statement is a classic representation of transitive property, but substitution property is also acceptable because if you look, what we did was we knew that every place that I see an angle K, I can replace it with an angle T. Here's an angle K, it gets replaced with an angle T. So you could look at it as transitive property or as substitution property. Okay, we're moving. All right, we're actually not going to move on to the next page. We're going to stop right here. For the rest of the examples, we will go over them in class together because they start to get a little more fun and exciting. So I'll see you in class.